Chapter 10, number 63. A bicycle is turned upside down while its owner repairs a flat tire. A friend spins the other wheel of radius .381 meters and observes that drops of water fly off tangentially. She measures the height reached by drops moving vertically in figure 1063. A drop that breaks loose from the tire on one turn rises to a height of 54 centimeters above the tangent point. A drop that breaks loose on the next turn rises 51 centimeters above the tangent point. The height to which the drops rise decrease because the angular speed of the wheel decreases. From this information, determine the magnitude of the average angular acceleration of the wheel.
From this figure, we can see that the water droplet goes off the bike at a point where it flies up straight up and down. It does not go side to side, and it goes up the height and then comes down.
Here we're given the radius, which is .381 meters. The height of the first drop, which is 54 centimeters, which we convert into meters, so it's .54 meters. The height of the second drop, which is 51 centimeters, and we convert that to 51 meters, and one rotation is 2 pi. And the find is the alpha, which is the average angular acceleration. To find the speed of the water droplets, we use 1/2 mv squared equals mgh. Solve for v, and we get v equals the radical of 2gh. Plug in the numbers for the first drop, and we find that the velocity is 3.25 meters per second. And then we move on to the second droplet and find that the velocity of that is 3.16 meters per second. We're asked to find alpha, which equals omega 2 squared minus omega 1 squared over 2 theta. And we need to find omega first, which is v over r. So then we plug in the numbers, which is, there it is, and find that omega equals 8.53 rads per second. Then we do it again for the second omega, and find that that one equals 8.29 rads per second. Back to the equation, and then we plug in the omegas and theta, and find that alpha equals 0.322 radians per second squared.